Good morning, dear students. Once again, this is Aniket Patnaik and I am here to discuss physics with you. I hope you are refreshed, recharged and ready to learn. So, in today's class, we are going to the next topics. We are going to discuss three topics today. Properties of charges, methods of charging and finally Coulomb's law. So, let's begin. First of all, let us start discussing the concept of properties of charges. The first property of charge is the additivity property of charges. Today we are going to learn something very interesting. We are not only going to discuss about the concepts, but we are going to learn the language of formulas. If you want to be good at physics, it is very important that you speak the language of formulas, you understand formulas. When you look at a formula, you must be able to decode the formula. At the same time, you must have the skill of converting a statement into a formula. So we are going to look into how we do that. Coming back to the topic, additivity property of charge. What is additivity property of charges? In the previous class, we discussed that if we want to charge a body, there are two methods of doing that. We have to add electrons or we have to remove electrons. Because as you know, it is very difficult to disturb the protons. So basically, we are going to add electrons or remove electrons. So the statement of the additivity property of charges is that it states that the total charge of a system is equal to the sum total of individual charges present in the system. So the total charge of the system, Qs, is equals to the sum of the individual charges Q1 plus Q2 plus Q3 plus Q4 so on plus Q10. So this is how we converted a statement into a formula, and this is the additivity property of charges. Now coming to the second property of charges, which is the quantization property of charges. In physics, there are going to be terms like quantization which seem scary, but they really aren't. Quantization is a very simple term. Whenever you use the term quantization in physics, it means a non-continuous quantity. Let me repeat that again. Quantized or quantization indicates non-continuous property of any physical quantity. What do I mean by that? When I consider a jug, if I pour water into a jug, the quantity of water increases continuously. You can take 1 ml, 2 ml, 3 ml, 4 ml, 5 ml. We can also take 1.2 ml, 1.3 ml, 1.4 ml, any value you want. Even if I want to fill the water to an extent of 1.75 ml, then I will be able to do that. So the value of water is increasing continuously. But what about climbing steps? If the height of one step is 1 feet, then I can go to the height of 1 feet, 2 feet, 3 feet. I cannot climb a height of 1.5 feet. So the values are not continuously increasing. The values are increasing in steps. So whenever the values are increasing in steps or in random quantities without increasing continuously, we say that the values are quantized. So why are charged particles quantized? That is the next question. When we come to the charged particles, I want to charge a body negatively. How do I charge a body negatively? I can supply it with electrons to charge it negatively. I have to add one electron, then two electrons, then the third electron, then the fourth electron. So if I add 4 electrons, how does the quantity of charge change? If I add 1 electron, the charge of the system becomes minus 1.6 into 10 to the power minus 19 coulombs, as we discussed in the previous class. If I add another electron, the total number of 2 electrons, then the charge becomes minus 1.6 minus 1.6 minus 3.2 into 10 to the power minus 19 coulombs. If I add another electron, the charge becomes minus 3.2 minus 1.6 minus 4.8 into 10 to the power minus 19 coulombs. So you can clearly observe a pattern here. The charge is either minus 1.6 or minus 3.2 or minus 4.8, and if you add one more charge it becomes minus 6.4. So the charge particles are not increasing, the value of charge is not increasing continuously. The value of charge is increasing in steps. Therefore, it is called quantization of charge. And now, let us convert it into a formula. We have understood the concept. When we charge a body, it is done by adding electrons. So, for example, if I add 10 electrons, what is the charge of the body going to be? Let Q be the charge of the body. We are adding 10 electrons. So 10 into charge of a single electron. Q is equal to N into E. As you can see the formula of quantization, Q is equal to Ne. Q is the charge obtained by the system, N is the number of electrons, and E is the charge of an electron, where E is equal to 1.6 into 10 to the power minus 19 coulomb. Again, what we have done here, we have converted our understanding into formula. So this was the concept of quantization. Now let us come to the third property, conservation of charge. I have changed the order of these two properties compared to the NCERT textbook for easier understanding. The third property is the conservation of charges. So I am very sure all of you must have heard about the conservation of energy. Energy is neither created nor destroyed. It can only be transformed from one form to another. Similarly, this is the concept of conservation of charge. You cannot manufacture charged particle in a factory. It is already made in the factory of creation. Charged particles are already present in each and every atom in the form of protons and electrons. You cannot create a charged particle. But if you want to charge a body, you have to transfer the electrons from one body to another body. Let us consider two bodies, body A and body B. If I want to charge B negatively, I have to remove electrons from A and transfer them to B. So B becomes negative and A becomes positive. So here I have not created charges. I am only transferring my charge particles from one body to another body, and this concept is called the conservation of charge. Now, since we have discussed the concept of properties of charges, let us come to the methods of charging. Methods of charging are basically methods of electron transfer from one body to another body. While there can be several methods of charging, today we are going to discuss two methods, which are rubbing and induction. So what is the process of rubbing? It is not, when you rub two bodies against each other, generally charge transfers from one body to another body. It is not true for any two bodies. One body should have the property to release electrons, another body should have the property to absorb electrons. For example, if I rub a glass rod with cat fur, the glass rod has a tendency to lose electrons and a cat fur has a tendency to gain electrons. So if I rub a glass rod with a cat fur, electrons are going to be transferred from the glass rod to the cat fur. And the cat fur is going to become negative and the glass rod is going to become positive. So coming to the next topic, now we are going to discuss about charging by induction. This is slightly different as compared to rubbing. In the process of induction, we are not going to bring two bodies in contact with each other. As you can see, it is very important to have a conductor in the case of induction, because as we discussed in the previous class, conductors have free electrons and charges can easily move inside a conductor. So when we bring a charged particle near to a conductor, in this case we have got a positive glass rod near to a sphere. The positive charges will be attracted by the negative charges and the positive charges are going to be repelled by the positive charges present in the sphere. So the negative charges are going to come towards the glass rod and the positive charges are going to go away from the glass rod. So this is a process of charging without bringing two bodies in contact with each other. So this is the process of induction.